and thank you for attending your laboratory this morning. So for our topic today would be your activity 7, also known as your osmotic fragility test. Now, in previous subjects you've encountered before, you would encounter the term or the word osmosis. Now, who can tell me what is osmosis, class? Ano ang osmosis? Narinig niyo na siguro yan. In your chemistry, in your general chemistry, in kung ano mang subject na ano nyo, you must have heard of it once or twice. So, can anyone tell me what osmosis is?
Movement of water, sir.
Movement of water? Movement of, hindi, malapit na. Movement of what in water? Movement of water into what? Molecules passing through a net movement of solvent to semi-permeable membrane. Okay, before that, medyo tama na si Miss Sarah. Okay, can anyone tell me what is a solute and what is a solvent? Para mas maintindihan natin. So we can easily understand what osmosis is. Because we're talking about osmotic fragility. Osmotic is related with your osmosis. So what is a solute and what is a solvent, class?
Solute is the one that is being dissolved in the solvent, sir.
Okay, and then what is a solvent?
The solvent is the material that is used to dissolve the solute.
So this is a liquid. Most times it is a liquid that dissolves the solute. So sabi nyo kanina, class, it is the net movement of solvent through a semi-permeable membrane. Now, when we talk about osmotic fragility, class, we are talking about the entry of water into your RBCs. Now, let's proceed. Now, your osmotic fragility test, class, would measure the capacity of red blood cells to withstand different saline concentrations. Now, in previous topics, I've mentioned that your normal saline solution, or your NaCl, sodium chloride, or NSS, is isotonic. And when a solution is isotonic, your red blood cells do not lyse. But, pero, if there is a kapag merong different concentration of your NSS or sodium chloride, it could become hypotonic. And when it is hypotonic, class, it would swell. And when it swells, it would lyse. Now, your osmotic fragility is a confirmatory test for hereditary spirocytosis. Now, if you recall, class, ang mga spirocytes nyo have decreased surface to volume ratio. And they would easily lyse when exposed to hypotonic solution. Imagine this would be your RBC. Now, imagine this would be your spirocyte. Your spirocyte would have a thin membrane due to decreased surface to volume ratio. And then when that happens, class, they would easily swell and then mag-burst sila or mag-lyse. Now, a counterpart of this would be your sickle cells and target cells. Your sickle cells and target cells, class, have increased surface to volume ratio. Thus, they are able to withstand osmotic pressure. Again, Your osmotic fragility test would measure the capacity of red blood cells to withstand different saline concentrations. It is a confirmatory test for hereditary spirocytosis. Your spirocytes have decreased surface to volume ratio. Thus, they would easily lyse when exposed to hypotonic solutions. While the counterpart or the opposite of your spirocytes is your sickle cell and target cells. They would have increased surface to volume ratio and is able to withstand osmotic stress. Now, to explain this further, here is your spirocytes class. Now, they would have a defect in the cell membrane proteins. Thus, they would lead to a decreased surface volume ratio. Now, if you notice, class, yung NRBC, yung normal RBC nyo would have a bi-concave shape. And manonotice nyo that they have a thick cell membrane. While for your spirocytes have a circular appearance or spherical appearance. And if you notice, they would have a thin cell membrane due to the defected proteins. Okay, again, your spirocytes are caused by defects in the cell membrane protein. They would have decreased surface to volume ratio. They would appear biconcave ang normal RBC nyo. They would have a thick red cell membrane. While your spirocyte would appear circular or spherical, thus they would have a thin cell membrane. Okay, let's talk about your isotonic and hypotonic solutions. Class, in your isotonic solution, there is what we call equivalent exchange of water. Now, we're talking about here your osmosis na. Now, there would be the movement of water into a cell. So, water would enter the RBC and the water would also exit the cell. There would be equivalent exchange. But in a hypotonic solution class, water enters the cell, but isn't able to go out, able to exit the cell. And kapag hindi makalabas, and when the water isn't able to go out, that would cause your RBC to swell. And when it swells, class, it would lyse. Now, in your osmotic fragility class, you're going to determine at what concentration of NSS or sodium chloride would it lyse. So, gaano ka resistant class to osmotic pressure at what concentration ba yung kaya niya na i-resist yung swelling. Again, in an isotonic solution class, there's what we call an equivalent exchange of water. Water would enter the cell and would exit the cell. But in an isotonic solution, water would enter the cell but isn't able to go out or to exit. Now, that would cause it to swell and to lyse. Now, in your osmotic fragility, you're going to determine at what concentration of sodium chloride would it lyse. So, would it lyse at 0.85% NaCl? Would it lyse at 0.80% Cl? And so on. So, we're going to use this sodium chloride solution as your determinant. So there are two known methods, class, for your osmotic fragility test. The first one is your Sanford method. The second one is your Daisy's method. Now, in your Sanford method class, this is an old test. This is a subjective tests. When you say subjective, it is based on the medtech's, based on MT's decision. Now, the reason why it's subjective class, because you would be observing for hemolysis. And this is a semi-quantitative test. So you're going to view for hemolysis, look for hemolysis. While your DASIS method classes, hemolysis is measured spectrophotometrically. This is a quantitative method. This is superior compared to the Sanford method. So you're going to use a spectrophotometer. Plus, can anyone tell me ano yung mga solutions na involved sa spectrophotometer? If you're gonna run a sample for your spectro, anong unang i-feed nyo? What are you gonna feed? Before you, okay, very good. The blank. Okay, so do remember the blank class. Mamaya, ano kayo. So again, your Sanford method, it is an old test. It is subjective. It is based on the medtech's decision. Hemolysis is visually observed. While your DASIS method, you would measure hemolysis spectrophotometrically. Very accurate class. Quantitative and superior compared to your Sanford method. Okay. The preferred sample class for your osmotic fragility is what we call the fibrinized blood. Now, from the prefix de, remove. And fibrinize would remove fibrin from blood. So, sir, how do we remove fibrin from blood? Now, if you recall, fibrinogen, when your blood clots class, fibrinogen becomes fibrin. Now, what you're going to do, class, to get the fibrinized blood, you're going to use a syringe and you're going to collect a venous blood. You won't be using any anticoagulant, walang anticoagulant class, because again, you need to remove the fibrin. Now, you're going to transfer it into a flask with glass beads. Then you're going to mix the flask by moving it in a figure of 8 motion. Continue until the sound of the beads cannot be heard. Plus, it was mentioned here that it has to have glass beads. Ano sa tingin nyo ang relationship ng fibrin sa glass beads? Based on what you know of fibrin class na tinuro ko, di ba ang fibrin nyo are net, parang net-like siya. That would attach, that would filter yung mga cells para mag-coagulate siya. So, what would be the relationship of your fibrin to the glass beads? Any ideas? Ang sabi ko ng prelim, ang fibrin nyo was a net-like structure or protein that would catch the cells and so on. So what would be the relationship of your fibrin to glass beads? Any ideas, class? Okay. So what happens here, class, is that your fibrin would adhere to the glass beads. Kasi diba they are a net-like structure. Thus they would attach to the glass beads, removing fibrin from the blood. And you have to do it in a figure of 8 motion class to, to be accurate on the removal of fibrin. Then the reason why you have to wait until the sound of the beads cannot be heard, because this is the time that the beads are fully coated with fibrin. Okay. So again, class, you would be using the fibrinized blood. You're going to use venous blood without anticoagulant. You're going to transfer that into a flask with glass beads. The glass beads would act as a structure that would cause the fibrin to adhere to them, removing the fibrin. Then you're going to mix the flask by moving it in a figure of 8 motion. Then you have to continue until the sounds of the bead cannot be heard. Now, when that happens, class, the beads are fully coated with fibrin. Now, the problem with the fibrinized blood kasi, class, this is not usually routinely used sa lab. Matrabaho to gawin. This is very tedious. So, an alternative that you could use is heparinized blood. So, you're going to use your green top tube. So, yung heparin nyo, you could use that. That would be your alternative sample. So if ever you're gonna be asked what blood sample is used in the fibrinized blood, first choice nyo would be the fibrinized, in osmotic fragility test, first choice nyo would be the fibrinized blood. Pag walang the fibrinized blood sa choices, go for heparin tube. Okay, let's discuss your Sanford method. In your Sanford method class, you have to prepare 14 test tubes. You have to label them from number 25 to 12. So 14 test tubes, label them from 25 to 12. So if you look at the table, makita nyo, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12. So you're going to label 14 test tubes starting from 25 to 12. Now, sabi ko kanina, I earlier said to you that we're talking about sodium chloride concentration. Now, along with sodium chloride concentration class, we're gonna use distilled water. So for each tube, bawat tube class, you're gonna add a corresponding drops of NaCl and water. Again, in your Sanford method, you're going to prepare 14 test tubes. Start from tube 25 to tube 12. After that, you're going to add each tube a corresponding drop of sodium chloride and distilled water. So for tube 25 class, you're going to use, for tube 25, you have to add 25 drops ng 0.5 sodium chloride and 0 drops of distilled water. For your tube number 24, you're going to add 24 drops of 0.5 sodium chloride and 1 drop of distilled water. Okay. After that class, so this would be your stock solutions. Yan na siya, yung mga tubes nyo na may laman ng sodium chloride and distilled water. The next thing you'll do, class, is you're going to add, so you have your 0.5% NaCl. Then you're gonna add your water. After that class, na-add nyo na yung drops ng sodium chloride, na-add nyo na yung drops ng water, you're now going to add a single drop of blood. So 1 drop of blood. Then you're gonna mix, then allow the tubes to stand at room temperature for 2 hours. Then, here comes the hard part, class. You're going to look for what we call complete hemolysis and initial hemolysis. So, sir, how would we know if it is a complete or initial hemolysis? Okay. A complete hemolysis class would be described by a clear red solution, while your initial hemolysis class is characterized by a slight pink coloration. Again, complete hemolysis is characterized by a clear red solution, while for your initial hemolysis, it is characterized by a slight pink coloration. So each tube class, babasahin nyo yun. From tube 25 to tube 12, you're going to look for complete hemolysis. Now, after you've found your complete hemolysis, you're going to calculate percent sodium chloride by multiplying the tube number indicating the hemolysis with 0.02. Okay, balik tayo dito. Let's say class tube 18. In tube 18, there is red, a clear red solution. Now that would indicate complete hemolysis. Now you have to get the percent NaCl. So what you're going to do is you're going to multiply the test tube number, which is 18, by 0.02. Saan may cellphone? Wait lang. Ang phone ko? Saan na ba? Okay. You would get, sorry class na calculator. Hinalo ko pa yung phone. 18 times 0.36. So thank you, Mr. Rado. So you would get 0.36% as your sodium. Ingat ka. You would get 0.36% NaCl. And report the computed values and note down the reference values. Okay? So I hope naintindihan nyo, class, yung Sanford method. May table naman yan lagi kasama. And to be honest, class, I've never done this method before. Hindi ko pa ito ginagawa itong osmotic fragility test na to sa practice. The reason for that, class, this is not a routine test. This is not a routine test, class. And there is very rare cases of hereditary spirocytosis sa Philippines. So this is not usually done. You may not even encounter this in your internship, but kailangan nyo rin ito maintindihan kasi. Okay. And mabalikan natin yan later. Let's go to your DASIS method procedure. Now, this time, class, kanina sa Sanford method, you're going to use 0.5% NaCl. In your DASIS method, class, you're going to use 1% sodium chloride solution. Then, instead of drops, class, hindi na drops ang gagamitin nyo. You're going to use ml of sodium chloride. So, kanina, 25 drops, 24 drops. This time, for your tube 1 class, you're going to use 4.25 ml of 1% NaCl and 0.75 ml of distilled water. Now, This time class, yung percent NaCl nyo is already given. And the total volume ng bawat tube nyo is 5 ml. Again, in your DASIS method, instead of 0.5% NaCl, 1% ang gagamitin nyo. Then instead of drops, you're going to use ml. So hindi na siya 25 drops, 24 drops. You're going to use 4.25 ml. Then this time class, you're going to label the tubes from tube 1 to tube 12. So kanina, 14 tubes, 25 to 12. This time, you have to label them from tube 1 to tube 12. So you're going to add, so nalagay nyo na class yung 1% NaCl plus distilled water. Kanina, you're going to add a drop of blood. This time, you have to add 0.05 ml of blood. Then allow the tubes to stand at room temp for 30 minutes. Kanina class, 2 hours in your Sanford. This time, 30 minutes. Then you're going to centrifuge the tube for 5 minutes at 2000 RPM. Extract the supernatant of the solution and measure the absorbance at 540 nanometers. So after centrifugation class, diba pag sinentry nyo ang isang specimen, there would be sediments here. So this would be the sediments. And yung liquid portion here, this is your clear supernatant. So this would be your clear supernatant. So you're going to take, kukunin nyo tong supernatant na to class, ipapipette nyo, and then you're gonna put this into a cuvette. After putting it in a cuvette, i-measure nyo siya sa spectrophotometer at 540 nanometers. Then you're going to use 0.85% sodium chloride as the blank. Ano yung 0.85 sodium chloride na yun, sir? Now, let's take a look at this. Your 0.85 sodium chloride class is your tube number 1. This is your blank. Yan ang gagamitin yung blank. Okay? So kapag tinanong kayo sa exam nyo, what tube would be used as the blank in your DASIS method? It is your tube number 1. Okay. Then after that class, you're gonna measure the absorbance, blah, blah, and you're gonna compute. Magko-compute tayo ng what we call percent hemolysis. Okay. Your percent hemolysis class, hindi kasi ito yung tamang PowerPoint. Okay. Current slides. Okay. Like that class, you're going to compute what we call the percent hemolysis. Now, to get your percent hemolysis, you're going to use absorbance X%. Now, your absorbance X% plus, this is the absorbance of the tube being measured. So when I say tube being measured, this would refer to your tube 2 to tube 12. Okay? So let's say if you need nyo si tube 2 class, you got a reading of 4.29. Then you're gonna subtract it by absorbance of 0.85%. Your 0.85% here class, absorbance 0.85%. This is the 0.85 sodium chloride tube, also known as your blank. Class, I have a question. In your spectrophotometer, what would be the result of your blank? All right, very good. It would be 0. That is why, class, Wait lang. Note to self, huwag gamitin ng laptop for games. Okay. Your 0.85% sodium chloride dito, class, is what we call your blank. It would represent no hemolysis. Sir, why is there no hemolysis? Let's go back to the contents of your tube 1. Your tube 1 class has 4.25 ml NaCl, while it contains 0.75 H2O. Anong sabi ko, class? Ang NSS nyo or your NaCl is isotonic. Kapag isotonic siya, class, walang hemolysis. But, the more water is added, class, mas madami yung tubig na dinadagdag, it would become hypotonic. The more water you add to NSS, it would become hypotonic. It would cause lysis. Okay? Naintindihan bakit walang hemolysis yung blank nyo? Because it has higher concentration of NaCl. Isotonic siya, class. But the more you add distilled water, the more it would cause lysis. Then you're going to divide it by A 0.0. Well, now what is A 0.0, class? This is the absorbance in the 0.0 sodium chloride tube. So tingnan nga natin kung merong 0.0 tube, wala. Walang 0.0 tube. It would end at 0.3. So I have a question, class. What do you think is the content of your 0.0 tube? Ano sa tingin nyo? Gaano karami yung laman niyang NaCl or water? Based on the movement ng table nyo. Walang ano, Amy? Walang total volume niya, 5 ml. Hindi pwedeng walang laman. Alright, very good. Walang NaCl sa episode. So it would contain 0 ml NaCl. And it would contain 5 ml H2O. Now, bakit siya 0.0? Let's look at the table, class. Na-notice nyo, habang pababa, as the concentration, as the percent NaCl goes down, the sodium chloride percentage also goes down. So if this reaches 0.0, expected na 0 ml ang NaCl nyo. But, your distilled water, class, habang bumababa yung percent sodium chloride, increases. So it is expected that at the end of this, you would have 5 ml H2O. Naintindihan? Again, if you notice sa table, yung percent NaCl nyo, as the concentration goes down, percent sodium chloride also goes down. But distilled water increases. Now, since we're looking at 0.0% sodium chloride, it is expected to have 0 ml 1% NaCl, but 5 ml H2O. Now, Your 0.0 NaCl tube class would represent complete hemolysis. Bakit complete hemolysis? Remember, water class causes lysis. Hypotonic yan. Kaya siya ginagamit alongside NaCl class. It is to determine the capability to resist lysis, swelling. Okay? Then you're going to divide it by 0.85%. So let's just say na ang nakuha niyong absorbance isn't zero talaga sa blank nyo. Let's say ang nakuha niyo is 0.01. Ang nakuha niyo dito sa ano is 6.28. Now let's try to compute. You would have 4.28 divided by 6.27 times 100. You would get 68.26% hemolysis. Now, how would we know, class, if it is partial, complete, or no hemolysis? Now, let's take a look at this normal values, class. Sabi dito, 68.26% hemolysis. So, dito siya, class. So, 50 to 90% hemolysis. And this would have a 0.40 NaCl concentration. Now, ano yung 0.40 NaCl? Let's take a look at this, class. Your normal biconcave RBC would show initial hemolysis at 45% NaCl. And complete hemolysis would occur between 0.35 and 0.30 NaCl. So, 0.30 to 0.35. So, itong dalawang to, this is your complete hemolysis. While your partial hemolysis naman, class, is between 36 to 45 NaCl. So, ito siya. This is your initial hemolysis. Well, this one would be your no hemolysis. Again, if you've already computed, class, your percent hemolysis, hanapin nyo siya sa chart. So we have 68.26. So dito siya sa 0.40% NaCl kasi 50 to 90% hemolysis. Then remember this rule. Kapag complete hemolysis, class, complete hemolysis would generally occur at 0.35 to 0.30 NaCl. So ito siya. This is these two. Itong dalawa na to would refer complete hemolysis. While your initial hemolysis naman, class, would have a value of 0.36 to 0.45 NaCl. So itong dalawa na to. While your no hemolysis would be 0.50 and 0.55 to 0.85 NaCl. Thus, you would have no hemolysis. Naintindihan? Gusto niyo ba ulitin ko? Did you understand that, class? Okay. All right, special considerations, class. Anticoagulants containing oxalates are undesirable because they may alter the pH. Then you should set up the test within 2 hours of blood collection or within 6 hours if the specimen is refrigerated. So, if you collected the blood at 10 a.m., you need to process it by 12 noon if i-room temp nyo lang yung specimen. If the specimen is set at room temp. But, If you're going to refrigerate it, you may process it until 4 p.m. So 2 hours kapag room temp, then 6 hours kapag ref temp. Then do not use anticoagulants containing oxalates because they may alter the pH. So clinical significance, you would have increased fragility in spirocytes, senescent cells or your old cells, hereditary spirocytosis, and autoimmune hemolytic anemia. While you would have decreased fragility in sickle cells or drepanocytes, target cells, chondrocytes or leptocytes, hypochromic cells, and reticulocytes. So here's the reference, and that class before mag-reporting tayo would be your total eosinophil count. So your total eosinophil count class has the same principle with your WBC count. So you're going to use a counting chamber. You're going to use a WBC pipette. The only difference class, ano yung diluent nyo in your WBC count? What is the diluent of your WBC count class? Naalala nyo? Hello, boy. Kumata ko. Yes. So, anong laman ng Turk's fluid? Turk's fluid ba? Anong laman? Anong nyo? Anong laman ng Turk's fluid nyo, class? What is the main component of your WBC? Diluent. Okay, you have your glacial acetic acid. So this time, class, you would have a different diluent sa total eosinophil count niya. So we have what you call the Fluxine diluting fluid. Now it has three main components. You have your propylene glycol, 1% Fluxine aqueous solution, and 10% sodium carbonate. Now, let's discuss their function. Your propylene glycol would lyse RBCs. Your sodium carbonate would lyse WBC except eosinophils. While your Fluxine is a dye that will make your AO appear red. Again, your Fluxine diluting fluid has three main components. We have your propylene glycol, which would lyse RBC, sodium carbonate would lyse WBC, and Fluxine, which is a dye that would make your eosinophils appear red. Now, the procedure class is you're going to make a dilution of 1:10. Now, if your dilution is 1:10, your dilution correction factor would be 10. But this time, class, merong kakaiba. You're going to use two WBC diluting pipette. Now, you may be wondering, why? Bakit dalawa? I'll explain that later. You're going to shake for 30 seconds. Discard several drops, then fill 2 chambers. Ano tong 2 chambers na to, class? If you recall, sa Neubauer nyo, it has 2 chambers, one at the top and one at the bottom. Each chamber would contain 9 large squares. Nalala nyo? So this time, kaya kayo may dalawang WBC pipette is because you're going to read in 2 chambers. After that, stand for 15 minutes in a Petri dish with moistened filter paper. Bakit may moistened filter paper, class? This would be for the prevent drying of the chamber. Bakit kailangan stand? You're going to stand it so that the cells, that RBC and other WBC would lyse, as well as so that the fluxine would penetrate the eosinophil, making them red. Making them red. Then you're going to count all eosinophils in 9 of each chamber. So what is your ACF class? Ano ang ACF niyo? What is your area correction factor if you're going to count 9 large squares? Hindi bisa ko po. Hindi. No, not 18. Bakit 225? Uy, hindi ka magbibilang ng medium square. You're just gonna count the entire large square. 9. 9 plus. But there's a rule. Yung dilution correction factor nyo. It's going to be multiplied by 2. 20. Bakit? Kasi you use 2 WBC diluting pipette. The reason hindi dumoble to because it's still the same chamber class. It has still the same area. But this time, you're using another pipette kasi. Okay? So, here's the formula class. Eosinophils per UL or cubic mm. So, this is your unit class. So, number of eosinophils counted times 20 divided by 9. Yung 20 nyo dito, this is your dilution correction factor. Your 9 here is your ACF. So, madali lang yung formula niya, class. Number of eosinophils counted times 20 divided by 9. Okay, here's an example, class. 8 WBCs appearing red and 12 purple were counted. Itong 12 purple na to, wala to. Panggulo ko lang yan, class. Remember, they would appear red because of the dye ng fluxine. So we have 8 times 20 divided by 9. You will get 160 divided by 9. You will get 70.78 per UL or 17.78 per cubic. Okay? Any questions for your total eosinophil count?